Okay, let's look at this DocSci NCHA exercise 24, number 5. This question is far more like what you would expect in an acid-base calculation in an exam, but it's a guided walk through one of those questions. So normally they would just give you the information and then ask you whatever this is at the bottom. But here's a guided walk through the question step by step to show you how to do it. So let's have a look here. It says to you 1,2 grams of impure calcium carbonate pellets react with 40 cubic centimeters of hydrochloric acid with a concentration of 1 mole per cubic decimeter. The excess hydrochloric acid that did not react with the calcium carbonate is neutralized by 25 cubic centimeters of sodium hydroxide solution with a concentration of 1 mole per cubic decimeter. So it says here, write down a balanced equation for the reaction between the hydrochloric acid and the sodium hydroxide. An acid plus a base gives you a salt and water, so hydrochloric acid plus sodium hydroxide gives you sodium chloride and water. And because the hydrochloric acid is a monoprotic acid, then we only have a ratio of 1:1 here. Now it says to you, calculate the volume of hydrochloric acid that was neutralized by the 25 cubic centimeters of sodium hydroxide. You need to realize that this is the excess HCl, okay? This is the HCl that is left over from the 40 cubic centimeters that was added. So let's go ahead and find it. We're going to use, it was titrated with the sodium hydroxide, okay? So we can use the titration formula. This neutralized here helps us see that it's an exact neutralization. So we're going to use this formula, CaVa over CbVb equals Na over Nb, where Na and Nb come from the coefficients from the equation. And whatever units you put in here for concentration and volume are going to be whatever you're going to get out. So we know here, what do we know here? Do we know the concentration of the acid? Yes, it says to you the concentration of the acid is 1 mole per cubic decimeter. We always like multiplying by 1. What is the volume of the acid? That is what we are trying to find. So we're going to put 1 times Va in there. And then this is over the concentration of the hydrochloric acid and the concentration of the I'm lying to you. It's the concentration of the base, CbVb, and the base is the sodium hydroxide, so it's 1 again for the base, because here in the question it says 25 cubic centimeters of sodium hydroxide solution with a concentration of 1 mole per cubic decimeter, times the volume of the base. This was 25, okay? And then this is going to be equal to the number of moles of the acid over the number of moles of the base, and we get this from the balanced reaction. So this is 1 divided by 1, which I do believe is going to give us 1. So if we substitute here, we're going to get Va over 25 equals 1, which means Va is going to be equal to 25. And my unit is going to be cubic centimeters because the other volume I put in there was cubic centimeters as well, okay? Now it says to you, calculate the volume of hydrochloric acid that reacts with the calcium carbonate. So we're going to find this by knowing what the excess is. We know what the initial, okay? So the initial minus the excess is going to give us what reacted, because whatever's left over is the excess, and it didn't react. So 40 minus 25, I do believe this is 15 cubic centimeters. Okay, so I hope you followed that, because whatever was reacted is no longer there to be neutralized by the sodium hydroxide, and we put in 40 cubic centimeters in the beginning. Now it says to you, write down a balanced reaction equation for the reaction between the hydrochloric acid and the calcium carbonate. This is an acid plus a metal carbonate, gives you a salt, carbon dioxide, and water. So here's my hydrochloric acid, here's my calcium carbonate, here's calcium chloride. Calcium is a valence of 2, so you need 2 chlorine ions to balance the calcium. Carbon dioxide and water. So to balance this, you need 2 hydrochloric acid per 1 calcium carbonate. So now it says to you, calculate the number of moles of hydrochloric acid that reacts with the calcium carbonate. Well, we've got the volume here, we've got the concentration in the question. So if we've got the volume and the concentration, we can find the number of moles using this formula. Concentration is the number of moles over volume. If we rearrange it, we get N equals CV. So N equals CV. Sorry for the big N. Autocorrect. So N equals CV, so my concentration was 1. Okay, now we found this to be 15 cubic centimeters. We can't put 15 cubic centimeters in there because our concentration is in moles per cubic decimeter. So we have to convert this into cubic decimeters, so it's 0.015. Okay, so that means the number of moles is going to be 0.015 moles. Okay, calculate the mass of calcium carbonate that reacts with the hydrochloric acid. Well, if we want to do this, we need to first find the mole ratio with the calcium carbonate. So what is the mole ratio for calcium carbonate to HCl? Let's have a look here. I'm in the wrong place. Let's have a look here. How many calcium carbonates? It's 1 calcium carbonate. Okay, 1 calcium carbonate plays 2 hydrochloric acids. So then if you look over here, if we've got 0.015 here, because we just worked it out, okay, this is going to be half of that. So this is going to be 0.015 divided by 2. Okay, so this is going to be, what is that? It's like 0.0075, 7.5 volt, sorry, times 10 to the negative 3. Okay, so now we found out how many moles of calcium carbonate react with the hydrochloric acid. If we want to find the mass of calcium carbonate, okay, first we're going to need to find the relative molecular mass, because the only formula that we've got relates moles to mass, uses the relative molecular mass. So I do believe calcium is 40 plus 12 for the carbon plus 3 times 16 for the oxygens, because there's 3 oxygens in here. You should end up with 100. Okay, that's the grams per mole. I'm not typing that in. That's the relative molecular mass. So now we know the number of moles, we know the relative molecular mass. We're going to use N equals M over M, but we can rearrange it to M equals NM. If you can't rearrange it in your head, put in the formula down properly, because too many people rearrange this wrong in their head and then they end up with the wrong answer, which is not a good thing. So this was what we calculated using the mole ratio, and then we're going to multiply this by 100. So that will give us a mass of 0.75, no unit, no mark, grams. Okay, so there were 0.75 grams of calcium carbonate reacting with the hydrochloric acid. So only the pure part of the calcium carbonate will have reacted. So the next question says, calculate the percentage calcium carbonate in the impure sample. So the percentage is going to be the pure over impure times 100. What happened there? Times 100. Okay, so to find the percentage, we have to take our pure over the impure. So we've got 0.75 pure. We're going to divide it by whatever was in the question here, 1,2 grams. Okay, over 1,2 times by 100, and we should end up with something. I get 62.5% pure. And that should be your final answer.